So we're going to talk about lesson 9.3, and we're going to talk about the review of effects on the parent quadratic function. F of x equals x squared, and then we're going to go over the vertex form. So we're at 5.4 today. So what I'm going to do is we're going to create a huge chart on this, and I think what I'm going to do is actually go on to the next full screen so we can get everything on there. Okay, so let's start with the vertex form. So the vertex form is a way to write an equation so that it reveals the vertex. And this, again, is highly touted in the last couple of years from the high school. So it does serve a very important purpose. It does. So the vertex form of a quadratic equation looks like this. F of x equals a times the quantity, x minus the h value, that squared, and then plus the k value. And we've talked about how h tells me how something translates horizontally, and how k tells me how something translates vertically. We talked about a telling me if we have a reflection and a dilation. Okay, so I get two things from that a value. Now, what's going to be interesting is the reason why I decided to kind of cut off and we're going to take a quiz on this is when we get to the next lesson, lesson 9.4, we're going to actually take equations and in a way turn them into this vertex form. Okay, so I thought let's just take a little bit more time with this, and then when we go the other direction, you go, oh yeah, I remember the vertex form. So what's interesting about the vertex form, not only can I tell what the parts, what's happening to my parabola compared to the basic f of x equals x squared, it also reveals the vertex, which is going to be your h value and your k value. Now remember, the sign on the h is not revealed. This is part of the formula, that subtraction. So what's hard is you need to understand that your h value sign is opposite to what it looks like it is. So we talked about if you just take that quantity, set it equal to 0 and solve, that's how you can determine whether you have a positive or a negative on it. Okay, so sometimes it's just a fail-safe, do that, and then you're proving what sign you have on it. So again, what's cool about this vertex form is this allows you to come up with the vertex quickly so that you can do your t-chart and you can graph from there. That does not preclude you from understanding how to do the axis of symmetry. Okay, you're still going to have to do that because if you notice on that sheet I showed you, axis of symmetry is identified. Okay, so you have to know how to do that. So your equation ends up creating a trinomial, a perfect square trinomial, so that when you factor it, you get a binomial being squared. So that's what this whole piece is. This is indicating factoring a trinomial square. And because not every equation is a trinomial square, we have to do some sort of adjustment to allow it to become one. So that's why we have these extraneous things, especially the k value. And sometimes there's a GCMF and we have to pull him out. And so that's where this is. This guy's, you're basically the GCMF of the equation. So again, when we talk about lesson 9.4, you're going to see in action us creating where this idea comes from. Okay? All right, so let's go and we're going to do our review chart. So our review chart is going to be based on this guy. the vertex form. F of x equals a times the quantity x minus h squared plus the k. So we're going to talk about what happens horizontally, vertically, reflection, dilation, and who's in charge of each of those. Okay? So everybody gets their 15 seconds of fame. Let's start with h. If you have an h value, it's going to tell you that you're going to have your x value move. So that's a horizontal change. Now again, we're always comparing to f of x equals x squared. So this is, how does this change based on f of x equals x squared? So that's what we're asking. How does it compare to that guy? So we had two values that we look for. If h is positive, so greater than 0, we're going to move right h places. And again, what I want you to understand is the sign tells us the direction to move. We take that sign off, and it's just the pure h value, or the absolute value of h, that tells us the number of places to move. And then if h is negative, we're going to move left. And again, just think about what the number lines on your coordinate system look like. Okay? You go to the right, it's positive. You go to the left of the origin, it's negative. So you're going to move left h places. So again, if you want to, if you need to, remind yourself that it's always the absolute value of h. The sign purely means direction. That's it. Okay? So that's h's 15 seconds of fame. That's his claim to fame. That's his starring role. Now, h equals 0 isn't one of the options, because that's where the basic function is. That's where the parent function f of x equals x squared is. His x value is at 0. Okay? So let's talk about k. And k, because he's away from the x squared, he's dealing with the y, so he is a vertical change. So up or down. And again, we broke it into two components. If k is positive, then you're going to move up k places, or k units. I keep using places, and I should say units. Now, notice that in the formula, the sign on k is the sign on k that we use. But the sign on h is opposite to what it looks like. So that's the hard one to keep straight. And if k is negative, you're going to move down k places. So again, you can use, or k units, you can think of k as an absolute, okay? The sign means down. You can't move negative direction, or negative numbers, okay? So those are the first two we talked about. And then A comes in. And A, man, he's the star of two parties. So A can deal with a reflection. So A can deal with a reflection. And what do we say A needed to be in order for the parabola to face upward? He needed to be positive. So if A is greater than 0, you're going to, there's no reflection and the graph opens up. And if A is negative, that's when we say it's reflected over the x-axis. So I'm going to write that underneath here. And we would have the graph opens and down, or downward. Okay? But then A performs another role. He performs a dilation. And the dilation isn't larger or smaller overall, it's skinnier or fatter is what it comes up with. So I'm going to list some words because, again, I think the book words are funny, but we're going to list them, and then I'll list kind of Rosner's translation. And you can do either. I don't know what the high school demands from you. So that way, this way you need to know both of them. So with A, if A is, let's see how to say this, the absolute value of A is greater than 1. What that allows me to say is that A is less than -1 and A is greater than 1. So we want numbers that are more than a physical 1. Okay, so if A is greater, absolute value of A is greater than 1. So your number is either smaller than -1 or greater than +1. Then you're going to have, your parabola is going to get skinny. So the book calls it stretch vertically. I say it gets skinnier. And again, what's happening is your parabola is closely approaching the y-axis. So it's going closer, because what's happening is that number is making your y values get larger faster, and that's what's happening. So you're shooting up much faster than the basic parabola. Okay, so a little picture of this. If this is your basic parabola, this guy is looking like this. Okay? Now, if your A value is between 0 and 1, and so how we deal with this, it's any fraction, so we can use that absolute value sign again. So if we have a fraction between 0 and 1 or between 0 and -1, then our parabola is going to either be called compressed vertically. So in other words, it's approaching the x-axis, it's widening out, and then I'm going to say it's wider, flatter, fatter, whatever you want to call it. It's up to you. I don't, as long as they make sense, either one's fine. I'm just telling you I don't know exactly what the high school is using for their language. So you need to be, because on the placement test they may be using the compressed vertically and the stretch vertically. So you need to know which one means what. Okay? Excuse me? Absolute value. So we're just looking at the number itself. So again, if this is your basic parabola, this is what compressed vertically means. So it's wider. Okay? So that's that.